So here we go, 4-6. I am really going to show you how to graph sine and cosecant and secant really quickly. It's going to be the quickest lesson of that part. Then we got to do tangent and cotangent, and we're on it like blue bonnet. All right? Thank you for helping me out so I could still help out the kids. Because they're so nice. Did you eat your little mint? How was the mint? Was it? Did you put it in the hot cocoa? What do we got? Here we got toast. Ooh, with jam. I love a good toast with jam. I like peanut butter and jam better, though. I do peanut butter on my toast. Do you guys do peanut butter on your toast?
I do. I don't think I'm weird.
I think you're weird. Just teasing. Okay, let's do the hardest one we can see on a secant, shall we? Is that fair? Secant. Y equals. Here it is, right here. 1/3 secant of pi halves x plus pi halves. I guess I could throw something on the end, but that really doesn't. Oh, okay, we'll do it. Minus 2. This is the hardest you're going to see. That's 1/3. I'll make it nicer for you. Guys, if you can do a secant, could you do a cosecant, do you think? What do you guys think a cosecant's the reciprocal of? Sine. So if I show you a secant, do we have to do a cosecant, do you think? Well, we'll do it anyway. Sure, what the hell. Okay, so I'm going to start with cosine first, ladies and gentlemen. Treat this like it just said cosine instead of a secant. Okay? So we start with our parent function. 0, pi halves, pi, 3 pi halves, and 2 pi. Okay, I got to pull this out first. I pull out the pi halves. I'm left with what? X plus 1. Whoever said that, good job. Was that you, Faith Shelby? Good job, Faith Shelby. Secant goes 1. Cosine goes 1, 0, negative 1, 0, 1, right? What are we going to do first? The pi halves, x. Okay, what does that do? Times is everything by what? 2 over pi, which becomes 0, 1, 2, 3, 4. Boop. 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 Next thing, we're going to do this plus 1. And I'm going to do the 1/3 at the same time just so I can save some time, if that's okay with you guys. Right, Ariel? That's what Sebastian would say. I don't know why he says Ariel instead of Ariel. Huh? He's a Jamaican crawfish? A crab?
Yeah.
Huh. You think he's really Jamaican? We're Googling that stuff. Why does Sebastian say Ariel instead of Ariel? Wow. A tramp, by the way. She calls her a tramp.
It's a Caribbean accent.
Does it say that?
It says,
Right there. And why is Sebastian the only person with a Caribbean accent? Okay, whoever said that, good job. Who brought that up? Nice job, Tim Smuin. Where did you figure that stuff out at?
At the end of Moana.
Really?
Yeah.
I missed that. Huh. Okay. All right, here we go. We just had some conversations, Nate. Where's the rest of your video? That was only a little snippet. No, I was on the bathroom, you know.
Understood. You have to go to the link in my bio. See the fucking Instagram doesn't let you post anything. But look how fancy my
No.
transcript is. That is crazy. As long as I have today's date on it, I think I'll be okay.
We'll find
If this
it.
is for the investors.
Then you better go to the mail and do it right now. You should
I'll do it
go.
as soon as I get the road as soon as
I'm good. I'm good.
you want fun dip?
Oh, I hate fun dip.
Thank
But
you.
I love you.
Here, anybody want fun dip?
Me.
I have one and two. Two with the guy with the hat. Yep, those were the two people. Even though you don't deserve a lot today. You got 20 dots of shames almost.
Don't pick them on. They'll come into your class.
She does have a lot of self-esteem.
Ask her.
What happened?
She erased a dot of shame first off.
Oh, that is pretty bad.
accidentally rubbed on it and then, I don't even know why I deserved the first one.
I don't either, but it doesn't matter. We don't talk about the past. All I know is you did not. You erased the dot of shame, and then I came with terror.
You guys got me cheating, huh?
No. Well, she was back there, but they've been here for a good 3 weeks. Hey, Winnie Witwit! I wish you were so more serious about class that you'd stay in it.
I know, right? I wish you would too.
I'm here! That's what I'm saying!
Oh, you got me.
I think I'm annoying her more than lately.
She's probably so glad you're going to feed her down.
I know, you should tell her about it. Okay, here we go. No, that was horrible. Not you're horrible. I'm horrible on my line right here. Appreciate you. Go get that. That's more important. Okay, here's -1. There's 0. There's 1, 2, 3. Anybody have a question? Okay, then we're at -2. Boop, boop. Then I'm up, so it's not very high. It just goes to there. This right here is -5/3. This is -7/3, okay? Make sense? Okay, here we go. So, it was it a negative? Nope, just regular. So it goes like such. Boop. 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 Okay. That's horrible. I need to stand up. I'm really sorry, guys. Sorry I'm lazy. That was not acceptable. And if people are talking behind their backs on me.
No, it's just very nice. Oh, I know, that's my different.
Okay. The what worked well? Okay, that didn't look very pretty, but it's because it's really, here, we'll make it better. We'll just start it again. Let's just start again, we'll make it a bigger scale. I'd rather have you guys know what the hell's going on. So there's -1, -2. Now notice, it's really right there and right there. Ooh, I'm really off on this. Okay, cosine, because it's a normal one, starts up top, midline, low, midline, high. Is that better? Okay. Now, the key thing, it's not every time it touches 0. Why is it not every time it touches 0 will be my asymptote? 0 is my original midline, isn't it? So anytime my graph touches the midline, that's where it's going to be a asymptote. So I touch an asymptote here, right? And I touch a midline here. And that makes sense, because what was my next rule that I brought up? Go off the hump, right? You see how he's a hump? So you go to that point, go off of it, and approach the asymptote. Here's a hump, go up. Here's a hump, go up. Okay? Now, that's only one cycle, right? If I continue on, would I get better and better at it? So if I did 4, that would probably be an asymptote, because notice we're going from pi to a midline again, right? So therefore, it approach. Does that make sense?
5.
The asymptotes come off of the midline. Exactly. And the really reason is, if I graph just cosine itself, this, my thing's off a little bit today. What's the reciprocal of 0? Here. What's the reciprocal of -1? -1, right? That's why you're still there. What's the reciprocal of 1? 1. That's why you're doing that. What's the reciprocal of a very small number? Very large. And then what do we do after that? We stretch it, and then we bring it up and down. That's why it's on a midline. Does that make sense to everybody? Yeah. So what I would do first, what I'm looking for is, I would have you graph exactly what the cosine graph is. Then off of that cosine graph, anywhere it touched the midline, I would do an asymptote. And then off of the asymptote, after I do that, I'd approach the asymptote by going off the hump and approaching. Does that make sense to you? So, here's what a sine graph looks like. Right? Correct? So notice we have an asymptote here, here, here. You're there with me? And then go off the hump. No. Does that make sense how you do a graph of a secant or a cosecant? Not hard, right? The bigger lesson today is how would I graph a tangent? That's what we're going to do right now. All right, just like we did yesterday, let's start by just plotting every point that we have to get an idea of really truly what it looks like, okay? Let's start with 0. Remember, tangent is y over x, right? What is y over x at 0? Well, the coordinate is 1, 0. So I take the 0, which is y, divided by 1. What do I get? 0. So the tangent of 0 is 0. What is the tangent of pi third? Not pi third, pi 6. Remember, it was 1/2 over root 3 over 2, which if I went ahead and did the reciprocal, it's root 3 over 3. Can somebody put that in your calculator, root 3 over 3 for me, please? 0.577. So here's 1. Pi third 6 is 0.577. What's pi fourth though? Remember, y over x at pi fourths are the same value, so it's just 1, isn't it? If I did pi third, it's root 3 over 2 over 1/2, which is just root 3. Root 3 is like 1.7 something, I think. Okay? So it's up here. And then at pi half, what happens? It's undefined. Because it's 0, 1, so 1 divided by 0 is undefined, right? So that's an asymptote. Okay? So notice, guys, what's happening here is it's not a straight line. It's a curve going like that. Yes, no, maybe so? Okay, if I continue on and I did, okay, what's 2 pi there? Oh, that's negative 1.77. So down here, just 3 pi 4 is negative 1. And then if I came over here to pi, there's another one here. When I came to pi, it's at 0. Ladies and gentlemen, look at this as well. Notice I started at 0, my back at 0. What was our definition of a period? One complete cycle. What's the definition of a cycle? You went to your highs of highs, lows of lows, and came back where you started. Have I went to the highest I could ever be? Have I been to the lowest I could ever be? And came back where I started. What's its period? Pi. Different. Tangent period is pi. Okay, really quickly, all I want you to do when you graph a tangent graph, here's your parent. Okay, 0 gives me 0. Pi force gives me 1. Pi halves gives me undefined. 3 pi force gives me negative 1. And pi gives me 0. I suck at graphing that part. Oh my heck. Is that better looking? Are you there with me? And that should make sense because notice this is quadrant 1. What is tangent in quadrant 1? Positive. What is tangent in quadrant 2? What's tangent in quadrant 3? And hence why if I continue on this pattern, what? That make sense? Yeah. So if I went backwards into quadrant 4 by going in the negative angle, then notice negative pi force would be down at negative 1, and negative pi halves would be at asymptote. Make sense? There's parent function. Do I have to go over everything else to do that again? Like the shift, it's the same shifting, right? It's different parent. Well, now what would cotangent look like? All right, so cotangent is the reciprocal of tangent, isn't it? So what's the reciprocal of 0? Undefined. So cotangent's in red. What's the reciprocal of 1? 1. What's the reciprocal of a very small number? Very large. What's the reciprocal of a very large number? Very small. So it's move closer and closer to 0. What's the reciprocal of undefined? 0. What's the reciprocal of negative 1? Negative 1. What's the reciprocal of 0? Right? I'll do that on a separate sheet. But all it is if you know tangent, you're just doing the reciprocal of it, right? So the key thing is you got to memorize this. That's what most people forget to do is memorize that this is tangent. Okay? And then cotangent, we'll hurry and graph that one more time just so you can see it on a nice piece of by himself. Remember, Tangent was 0 here, so what's the reciprocal of 0? Undefined. At pi force, that was at 1. What's the reciprocal of 1? 1. At pi halves, tangent was undefined. So what's the reciprocal of undefined? 0. Reciprocal of 3 pi force, which was negative 1. What's the reciprocal of negative 1? Negative 1. And then pi was 0. What's the reciprocal of 0? Undefined. And hence, okay, so what would it be our chart on this one? Still have those nice ones. You still have 0, pi force, pi halves, 3 pi force, and pi, but this time I'd have undefined, 1, 0, negative 1, undefined. I do have some, you want some, like, hand stuff, whatever the hell that stuff's called again. Sanitizer. What did you say? No, don't eat that stuff. Don't listen to him. Did you really eat it? I don't remember that question. Do you need to go to the bathroom? All right, I was offering. Understand why I asked you that? Huh? You don't understand? Does anybody want to help her? You gonna be okay with it? All right. Don't say Mr. Roberts never gave you an opportunity to help you out in life. Right? That's why I was trying to help you. Ladies and gentlemen, where does the secant of x equal 2 root 3 over 3? I want you to do this without a machine. So what I do is, I can't think of secant. I still don't, and I've been doing this a long time. But I can think in cosines, which this would be cosine of x equals 2. 3 over 2 root 3. I'm going to hurry and just rationalize. I was right at 46. Oh, you're wrong. Oh, my bad. I do that. You were so proud of yourself. I'm sorry.
I thought I got mixed up with tangent in my head, so I was like, I do not know that.
Root 3 over 2. So remember, cosine's the x value. Where's your x value? Root 3 over 2. Pi 6 and 11 pi over 6. But notice they did ask for x to be between 2 pi and negative 2 pi. So that we've done 0 to 2 pi. So we need to do now 0 to negative 2 pi. So we just basically say, what is coterminal to these? Who's coterminal to 11 pi 6? Negative pi 6. Who is coterminal to pi 6? Negative 11 pi 6. That it? Feel good? This is the easy lesson day. Because I think it's pretty easy. The thing people get mixed up with, what do you guys think the biggest thing they get mixed up today? The period. Because cosine and sine have 2 pi. And they forget the period of tangent is pi. What's the period of cotangent as well then? Pi. Does that make sense? 1 through 47 on. What section is this? 4-6? Odds.